Let us continue. Now, the high process side valve may be installed on the basis of condensing unit or near at the base of the condensing unit, means at the base of the condenser or near to the evaporator, as it depends on the liquid level of the evaporator. Now, when it is installed at the base of the condensing unit, the liquid light from the float to the evaporator will frost or sweat. Liquid light from the float to the evaporator will either frost or sweat. In order to overcome this undesirable condition, liquid light is insulated so that there should not be a transfer of heat. To explain, another way of preventing the frosting or sweating condition is to provide an intermediate pressure in the liquid light. This valve essentially weighted little valve. The weight in such it takes 1.75 bar to 2.1 bar. That low side pressure means that pressure in the liquid light between the high side float and intermediate float pressure valve is high enough so that the saturation temperature of the liquid is above the dew point temperature of the surrounding air at which the frost or sweat becomes. So what is the weight? To prevent the frost or sweating conditions, to provide an intermediate pressure valve in the liquid light near the evaporator, means here weighted twinkle valve means it carries due to the weight. The weight is essentially weighted twinkle valve. The weight is just 1.75 to 2.1 per meter to the low pressure side. This is this means the pressure in the liquid light between the high pressure float and the intermediate pressure valve is high enough so that the saturation temperature of the liquid is above the dew point temperature of the surrounding air, at which the frost or sweat becomes. Thus, there will not be any frost or sweat. In this application, where the high side float valve is installed on the top of the refrigerator near the evaporator, no intermediate pressure valve is needed because the liquid light is inside the cabinet. The refrigerant liquid level in the high pressure system is critical, so that liquid refrigerant causes flooding the suction line, and so very little refrigerant causes a low evaporator level, resulting in low capacity of the refrigerating system. Okay, let us go through another one.
हेलो दोस्तों, आप देख रहे हैं ASR सर्विस सेंटर। सर्विस सेंटर में आपका स्वागत है। मैं हूं मरजीत फ्रॉम उत्तर प्रदेश गोरखपुर से। आज ये वीडियो में जानने वाले हैं कैपिलरी ट्यूब के बारे में। कैपिलरी ट्यूब दे सकते रहेंगे और फिल्टर ड्राई दे सकते रहेंगे। ये चीज़ हमारा डिवाइस इंपॉर्टेंट पार्ट है जो रेफ्रिजरेटर साइकिल में यूज होता है। यानी कि विंडो AC हो गया या स्प्लिट AC हो गया या फिर फ्रिज हो गया या फिर वाटर कूलर हो गया या फिर एक्सपेंशन डिवाइस के लिए बड़े सिस्टम में भी ये यूज होता ही है। एक्सपेंशन का काम जरूर होता है। इंपॉर्टेंट डिवाइसेस है जो ये लगा ही रहता है। तो ये कैसे वर्क करता है, यहाँ से कूलिंग कैसे उत्पन्न होता है, ये एक जादू का पुड़िया इसको बोल सकते हैं, जो यहाँ से हमारा कूलिंग होता है। अगर ये नहीं रहेगा तो शायद कूलिंग पॉसिबल नहीं होगा इसके मेटरिंग डिवाइस के बिना। तो ये कैसे वर्क करता है, इसका साइज कितना में साइज आता है, कैसे वारंटी करेंगे, कितना टन में कैसा लगेगा, कितना टन में कितना साइज का प्राइस लगेगा, या फिर स्प्लिट AC में या विंडो AC में कितना साइज का आता है और उसका साइज क्या रहता है। अगर आपको इसके बारे में मालूम है तो वीडियो को स्किप कर सकते हैं, नहीं मालूम है तो पूरा वीडियो देखिए, आपको जरूर जानने सीखने को मिलेगा। अगर ये वीडियो आपको अच्छा लगता है तो लाइक कर सकते हैं, नहीं तो आप डिसलाइक कर सकते हैं। सब्सक्राइब करें हमारे इस चैनल को और साथ में इस बेल घंटी को भी दबा दें, जिससे और भी इस तरह से हम वीडियो बनाएं, आप लोग पास भेज सके, आप लोग भी सीख सके, देख सके। आप लोग भी नए टेक्नीशियन लोग का हेल्प जरूर करें। तो कैपिलरी ट्यूब के जाने से पहले हम एक रेफ्रिजरेटर साइकिल जो रहता है इसके बारे में हम जान लेते हैं। देख सकते हैं रेफ्रिजरेटर साइकिल जो रहता है इसका फंक्शन कैसा रहता है। इसमें जो हमारा कंप्रेसर को इंपॉर्टेंट डिवाइस क्या क्या चीज़ इसमें हम बता देते हैं। नॉर्मल एक हमारा आ जाता है कंप्रेसर आ जाता है। कंप्रेसर के आगे कंडेंसर आ जाता है। कंडेंसर के आगे जो आपके हमारे जो फिल्टर आ जाते हैं, या फिर फिल्टर कहा जाता है, या फिर फिल्टर ड्रायर के नाम से जाना जाता है, या स्टेनर के नाम से जाना जाता है। उसके बाद आता है कैपिलरी ट्यूब रहते हैं। कैपिलरी ट्यूब रहेगा। उसके बाद हमारा आता है इवापरेटर से फिर हमारा आगे बड़े बड़े सिस्टम है, तो उसमें लिक्विड रिसीवर आएगा, सेपरेटर आएगा, यानी कि और अलग एक्स्ट्रा सा डिवाइस आ जाते हैं। लेकिन मेन जो पार्ट्स हैं इसमें आप देख सकते रहेंगे यही सब कुछ पार्ट्स मेन है, जिससे हमारा कूलिंग होता है और सिस्टम रेफ्रिजरेटर साइकिल जो वर्क करता है, चलता है। तो इसका जो है वीडियो में हम सबसे इम्पोर्टेंट हमारा पार्ट्स है आज का कैपिलरी ट्यूब मीटरिंग डिवाइस। जो कैपिलरी ट्यूब जो है कैसे वर्क करता है, क्या सिस्टम रहता है, इसके बारे में हम जानने वाले हैं। ये बोला जाए तो जादू का पुड़िया है, इसको आप बोल सकते हैं जादू का पुड़िया, जो यहाँ से हमारा कूलिंग जो है आगे स्टार्ट होता है। इसके बिना जो हमारा कूलिंग शायद प्रॉब्लम हो सकता है, सही प्रॉब्लम सॉल्व नहीं हो पाएगा इसके बिना। तो एक जादू का पुड़िया है। इसको वर्क कैसे करता है, कंप्रेसर रेफ्रिजरेटर साइकिल देख लेते हैं। हमारा जो है कंप्रेसर हाई प्रेशर हाई टेम्परेचर से गैस को वेपर में भेजता है कंडेंसर में। कंडेंसर का काम क्या रहता है, कंडेंसर जो रहता है हीट को निकाल करके उसे लिक्विड में, हाई प्रेशर से हीट को निकाल करके उसे लिक्विड में कन्वर्ट हो जाता है। लिक्विड में कन्वर्ट जो रहता है उसमें जो हमारा पूरा फुल परसेंट 75% रहता है, लेकिन उसमें 25% जो रहता है हमारा वेपर ही रहता है, लेकिन 75% लिक्विड में कन्वर्ट हो जाता है। वहाँ से कन्वर्ट होकर के आगे जो हमारा जाता है, जिसे ड्रायर कहा जाता है, या फिर स्टैनर कहा जाता है, या फिल्टर ड्रायर कहा जाता है, वहाँ पर जाता है। वहाँ पर जो है फिल्टर होकर के, फिल्टर के अंदर जो जाली रहते हैं जो गैस को रहता है फिल्टर करता है। फिल्टर क्योंकि कैपिलरी ट्यूब रहता है ये बहुत ही बारीक होल रहता है। इसका पॉइंट जो है इसमें देख सकते रहे 0.5 mm जो है डायामीटर इसका रहता है। अंदर का साइज जो रहता है 0.5 डायामीटर से लेकर के 1.5 डायामीटर रहता है इसका। उसके बाद इसका लेंथ जो रहता है, इसका लेंथ अगर बात किया जाए तो 0.5 मीटर से लेकर के 6 मीटर के आसपास ये आता है। ये 6 मीटर के 0.5 मीटर से लेकर के 6 मीटर के आसपास ये आता है इसका साइज। तो इसका जो साइज जो रहता है इसका डायमीटर के हिसाब से, और एसी का कितना टन का है, कितना बड़ा एसी है, छोटा सिस्टम है, रेफ्रिजरेटर साइकिल हो गया, फ्रिज हो गया, या एसी होगा, कितना बड़ा है उसके ऊपर डिपेंड रहता है। यानी कि इनडोर से आउटडोर में कितना दूरी है, कितना डिस्टेंस है, उसके ऊपर डिपेंड रहेगा, या कितना प्रेशर का जा रहा है, कितना बड़ी कैपेसिटी है, उसके ऊपर डिपेंड होता है। कूलिंग कैसे होता है, कूलिंग जो होता है इसका हाई प्रेशर, यानी कि इसमें जो हमारा कंडेंसर जो रहता है वो हाई प्रेशर वेपर से जो हमारा हाई प्रेशर और हाई टेम्परेचर से निकल करके कंडेंसर होकर के, कंडेंसिंग होकर के ये लिक्विड में कन्वर्ट होकर के हमारा आगे एक्सपेंशन में जाता है, यानी कि कैपिलरी ट्यूब में जाता है। वहाँ से काम इसका क्या करता है, हाई प्रेशर को ये लो प्रेशर लिक्विड में कन्वर्ट कर देता है। कैपिलरी ट्यूब रहता है, इसका होल जो रहता है वो पतला रहता है, और इसके ज़्यादा टर्न की वजह से, ज़्यादा घुमाव की वजह से इसमें जो है लो प्रेशर में हो जाता है। जहाँ पर अगर लो प्रेशर होगा तो ऑटोमेटिक जो है लो टेम्परेचर भी हो जाएगा, लो टेम्परेचर हो जाता है इसका। हाई प्रेशर से इसके लो प्रेशर में आएगा और लो टेम्परेचर में भी हो जाता है, कन्वर्ट हो जाता है, जिसकी वजह से इवापरेटर में जाता है। वहाँ पे पाइप जो है आकार जो बड़ा रहता है, पाइप का जो है नॉर्मल इसकी अपेक्षा जो है कैपिलरी ट्यूब जिसका पतला रहता है, इवापरेटर का उसका आकार जो रहता है, पाइप जो रहता है मोटा रहता है। वहाँ पर जो है एक्सपेंड होता है, यानी कि यहाँ से पतला पाइप से देख सकते रहेंगे किस तरह से एक्सपेंड होता है। यहाँ से पतला पाइप से आगे अगर फुहारा जाता है तो प्रेशर उसका फैल जाता है। प्रेशर फैलने की वजह से ये तुरंत जो है लिक्विड में कन्वर्ट हो जाता है, लिक्विड में ऑलरेडी रहता है, फिर वहाँ से और भी ठंडा हो जाता है। जैसा कि आप एग्जांपल आप देख सकते रहेंगे, आप ऐसा फील कर सकते हैं, महसूस कर सकते हैं। आप सांस लेते हैं, ऐसा एग्जांपल, अगर आप इस तरह से सांस छोड़ेंगे, डायरेक्ट आप हाथ लगाएंगे, आप डायरेक्ट से मुँह खोल करके डायरेक्ट सांस छोड़ेंगे तो आपको यहाँ पे हाथ पे गर्म फील होगा। वही चीज़ आप पे जो है डायरेक्ट आप इस तरह से मुंह को पतला करके आगे हाथ छोड़ते हैं, एग्जांपल अगर इस तरह से मुंह को पतला करके इसको हवा प्रेशर मारते हैं, यानी कि अंदर से दबाव ज़्यादा आ रहा है, यहाँ मुंह पतला हो रहा है, आगे जो एरिया बड़ा हो जा रहा है, फैल जा रहा है, तो यहाँ आपको फील करेंगे यहाँ ठंडा हो जाता है, क्योंकि प्रेशर जो है हाई प्रेशर यहाँ से लो प्रेशर से आकार जो बड़ा हो जा रहा है इसमें, यानी कि हवा जो है कम में ही रहता है, लेकिन ज़्यादा एरिया कवर करने की वजह से वो लिक्विड में ही कन्वर्ट हो जाता है। लिक्विड ऑलरेडी रहता है लेकिन और भी ठंडा हो जाता है, क्योंकि इसमें रेफ्रिजरेंट का ऐसा गुण रहता है, हाई टेम्परेचर थोड़ा सा भी अगर गर्म मिलेगा तो वहाँ पर ये वेपर में कन्वर्ट हो जाता है, और जहाँ पर इसको ठंडा थोड़ा सा भी मिलेगा, गैस को थोड़ा सा भी जहाँ पर ठंडा हुआ तुरंत ये लिक्विड में कन्वर्ट हो जाता है। यानी कि ये वर्क ऐसा ही करता है, यहाँ से जो लिक्विड में थोड़ा सा कंडेंसर से कंडेंसिंग जो निकल जाता है, हीट को निकाल लेता है, और उसके बाद धीरे धीरे जाता है कैपिलरी ट्यूब से वहाँ से ये लो प्रेशर में कन्वर्ट हो जाता है, लो प्रेशर लो टेम्परेचर में कन्वर्ट हो जाता है। उसके बाद कूलिंग हमारा इफेक्ट स्टार्ट हो जाता है, कूलिंग में बन जाता है। तो इस तरह से रेफ्रिजरेशन साइकिल का सिस्टम जो रहता है वर्क करता है। अगर आपको वीडियो में अच्छा लगा है, कुछ सीखने को मिला है, तो आप हमारे चैनल को लाइक कर सकते हैं, इस वीडियो को लाइक कर सकते हैं, नहीं तो आप डिसलाइक कर सकते हैं। आशा करता हूं आप लोग को ये वीडियो में जरूर कुछ जाने सीखने को मिला रहेगा। अगर आपको जाने सीखने को मिला है तो वीडियो का फीडबैक जरूर दें, इसका कमेंट करें कि आपको क्या चीज सीखने को मिला है, क्या चीज अच्छा लगा है। आप लोग देख सकते रहेंगे हमारे इस सर्विस सेंटर पे बहुत से टेक्निकल वीडियो हैं, जो हमारा एयर कंडीशनर, रेफ्रिजरेटर, वॉशिंग मशीन, फ्रिज, कूलर, मोटर्स, पंखा, हर चीज जो भी हमारा होम इक्विपमेंट, जो भी हमारे घर में यूज होने वाले इलेक्ट्रिकल्स मैकेनिकल्स आइटम्स रहते हैं, उस सबको रिपेयर करने के लिए हमारा इस चैनल पे बताया गया है, सिखाया गया है। अगर आप एयर कंडीशनर, रेफ्रिजरेशन सिस्टम जो भी आप ITI डिप्लोमा, इलेक्ट्रिशियन का ITI डिप्लोमा वगैरह कर रहे हैं, तो चैनल आपके हेल्पफुल रहेगा। इस पर हम आप लोग को थ्योरिकली से लेकर के प्रैक्टिकली वीडियो बहुत से हम बनाने वाले हैं, और भी हमारे बहुत से बना हुआ है आप लोग के हेल्प के लिए। आप लोग बस जानना चाहते हैं, सीखना चाहते हैं, तो हमारे चैनल को सब्सक्राइब कर लें। सब्सक्राइब करने के बाद जो बेल आता है उसको ऑन कर दें, जिससे और इस तरह से हम वीडियो बनाएं आप लोग के हेल्प के लिए, आप लोग के पास हम भेज सके और आप लोग भी सीख सके, दे सके। आप लोग भी नए टेक्नीशियन, नए लोग का हेल्प जरूर करें। आज आपका दिन शुभ हो। थैंक यू फॉर वॉचिंग।
I welcome to my YouTube channel. In this video I discuss you in details about the capillary tubes, its constructions, why its diameter is smaller or larger, means how to select its diameter and lengths, what's its advantages, disadvantages, and its complete working. So first we start from this figure. So this is the capillary tube. So it is installed between the condenser and evaporators, and it is used to reduce the pressure of the refrigerant from condenser pressure to the evaporator pressures. So these liquid refrigerants coming from the condenser is supplied inside the capillary tubes. In that tube pressure is reduced. So how the pressure is reduced, that discuss later on the video. Then after pressure reducing, it is supplied into these evaporators. Okay, so this capillary tube is the simplest type of refrigerant expansion device or the flow control device. So capillary tube is generally constructed from the copper, have a very small diameters and certain lengths. So it is widely used in the smaller capacity of the systems, that is generally used in our freezer, fridge, air conditioning systems, water cooler. So in that smaller units we use the capillary tube. Now this capillary tube have a certain diameter and a certain lengths. So it is available on the different diameters and the different lengths. The copper tube have an internal diameter of 0.5 mm to the 2.25 mm, and its length varies from 0.5 meter to the 5 meters. Okay, so diameter is given in mm and the length is written into the meters. So according to the different applications, according to the requirement of the pressure in the evaporators, we are able to select certain diameters and the length of the tubes. Then it is capillary tubes is installed between the condenser and the evaporators in the liquid line. And this pressure drop, means how the pressure drop is done in the capillary tube. So this pressure drop of the refrigerant in the capillary tube due to the frictional resistance offered by the small diameter tubes. Okay, so refrigerant is coming from the larger diameter tubes. Now when it is supplied into this smaller diameter tube, means in the capillary tubes, it's offered some frictional resistance, and due to this frictional resistance its pressure is reduced. Means this flow of the refrigerant adjusted on such a way that the pressure drop inside this tube, means what amount of this pressure drop is done in this capillary tube is equal to the pressure difference between the condenser and evaporators. Okay, and this pressure drop is directly proportional to the length. Means if we increase the length of the capillary tube, then pressure drop is increased. Okay, because it is directly proportional. So delta P is directly proportional to length. So length is increased, pressure drop is increased. And this pressure drop is inversely proportional to the diameter of the capillary tube. That means if we increase the diameter of the capillary tube, pressure drop is reduced. So if we require the higher pressure drop, then we select the smaller diameter of the tube. Okay, and that is a number of possibilities. Suppose we require to change in the pressure from the condenser to the evaporator is 6 bar. So from this 6 bar pressure difference, there is a number of diameter and length is possible. Okay, that is a not in single tube is possible. If we select the 1 mm diameter, then length is different. If we select the diameter of 0.5 mm for the capillary tube, then its length is different. So number of possibilities for the different diameters and the different lengths. When we select the particular diameter and length tube for the certain pressure drops, so it is a fix for the particular systems. Then after we are not modified on that. If you learn something, then like my video and subscribe my channel. Next we study the advantages and disadvantages. So advantages of this capillary tube is that it is a simple in construction, no maintenance is required, its cost is also lower. When the compressor stop, it allowed high and low pressures to equalize. Means when we stop the pressures, then it start to mix with the low pressure refrigerant in evaporator and high pressure in the condenser. Means it's a mix, and after sometimes we are achieving the same pressure for the voltage systems, and according to that smaller low starting torque motor can be used. Okay, so smaller size motor or the smaller starting torque motor we can use in the compressors. Receiver is not required when we install the capillary tubes. Its cost is also considerably low because the copper tube is coming in the very low cost. Disadvantages is that refrigerant must be free from moisture and dirt, otherwise it will be choked the tube and stop the flow of refrigerants. So if there's certain moisture inside the systems, so this moisture is converted into the ice inside this tube, capillary tube, then it's choked the system, means flow of the refrigerant is stopped inside the system. So system is must be free from the moisture and dirt. Thank you for watching this video. If you learn something, then like my video, subscribe my channels and share with your friends.
Capillary tubes. Hey, this is a type of metering device that's used in small commercial refrigeration equipment like reach-in cooler boxes or small prep tables. And the capillary tube is used because it's a rather inexpensive type of metering device, and it works very well for this type of application. The one thing about the systems that have capillary tubes, it's designed to maintain the temperature of the product, really not to drop the temperature of the product. So at the beginning of the day, for example, at a pizza restaurant, they'll take out all the toppings for the pizza from a walk-in cooler, and they'll put it in their little prep table cooler or a small reach-in box, and they're already putting the cold product into the box, and the box does a great job of maintaining the temperature, not a very good job of dropping the temperature. So the capillary tube falls in the category of a fixed metering device, and like all metering devices, it regulates refrigerant flow by dropping the pressure. And unlike a fixed orifice or a TXV, that pressure drop is determined by the length of the cap tube and the diameter of the cap tube. Now here's a great example of how a cap tube works. it's just like your garden hose. If you have 100 psi of pressure coming out of your spigot and 25 feet of hose, for example, you'll have 75 psi of water coming out the end of the hose. And the reason this happens is because of the friction of this hose drops the pressure of the water coming out. Now you take that same water spigot at 100 psi and put on 200 feet of hose. You probably already had this happen. You hardly have any water coming out of the end. This is the same principle as cap tube. So the longer the cap tube is, the more the pressure drop is. Now it provides a consistent pressure drop. So as the condensing pressure goes up, the evaporator pressure will go up, and vice versa. So when the condensing pressure goes down, so will the evaporator pressure. Now here's an example of a cap tube, and many times these cap tubes in the system will be 5, 6, 7, 8, 9, 10 feet long, depending on the application. And these inside diameters are going to be very, very small. And basically that's it, just a tiny tube where the refrigerant flows in one end and out the other. Okay, so here is some information from JB Industries, and they manufacture cap tubes. And this is one thing to remember when you're taking a look at a cap tube system, that the cap tubes depend on their length as well as their diameter to determine the total pressure drop or restriction. So if you have a change in diameter and you put the wrong cap tube in, even by less than 5/100ths or 5/1000ths of an inch, it is going to double the flow of the refrigerant. So you need to really make sure that if you're replacing a cap tube, you have the right one. So you have to remember this: the longer the tube, the slower the flow; the shorter the tube, the faster the flow of refrigerant. Okay, so sometimes it's pretty easy when you have to replace a cap tube. You can check with the equipment manufacturer with the model and serial number of the piece of refrigeration equipment, and if it's not available, you can get the size of the equipment from the compressor. So what you would do is, here's an example: you have a 1/3 horsepower unit, and you want to keep the evaporator temperature at 15 degrees, and the existing cap tube size is 0.036 inches inside diameter and 6 feet long. So here's what you do. So you can't get a hold of the manufacturer. They don't want to wait, and if you do, the customer doesn't want to wait a week for you to get it ordered and get it in. So here's what you do: is you look for the 1/3 horsepower. Let's go back. So we have the 1/3 horsepower unit, R22 system. The operating temperature is 5 to 20 degrees. So you go back here, we're at 15 degrees evaporator. And this tells you that for the JB chart, and this works for all cap tube manufacturers, that you need 6 feet of model number TC36. So there's also a conversion chart, and this is again where someone doesn't want to wait to see if you can get, doesn't want to wait for days to get the proper sized cap tube in from the manufacturer. So let's take a look at how that conversion chart would work. You know that you have 9 feet of 0.04 cap tube is needed, and you can only get 0.036 cap tube at your local supply house, or maybe you can only get 0.042. So let's take a look. So here's how this works. Here's the original tubing, and I'm going to show you how you can figure out the inside diameter of the tubing later, but it's 0.04 inches. So the only cap tubes you can get are either 0.036 inches or 0.042 inches. And they just have a multiplier down here. So you read over from the original size and you read up to the size that's available, and there's a multiplier of 0.62. So if there's 9 feet of 0.04 inch diameter cap tube, you multiply it by 0.62, and it tells you need 5.5 feet of this size cap tube. And also, if you have only 0.042 that you can get, here's your multiplier. Same thing, 9 feet times 1.25 equals 11.25 inches of cap tube. So if you get in a pinch and you can't find the exact diameter, there are conversion charts that'll allow you to do that. Okay, one of the things to remember, if it has a larger diameter, you have to have a longer piece of cap tube to get the same amount of pressure drop. And if it has a smaller diameter, it has to be shorter. So just keep that in mind when you're, if you have to resize to a different size cap tube. Here's a good example. 0.031 inch cap tube has the same pressure drop at 5 feet as a cap tube that is only 5/1000ths of an inch larger. So look at this, 5 feet at 0.031 is equivalent to 10 feet of 0.036 and 21 feet of 0.042 inch cap tube. So each one of these examples gives the same pressure drop to the evaporator coil. Okay, so for a cap tube system to work, you need to make sure that it is sized properly, and the evaporator load must be at design conditions. Remember, we talked about it is only designed to maintain the temperature of product that is removed from a cooler, a walk-in cooler, and put in there to be used throughout the day. So if you put in several heads of lettuce that were at room temperature, it might take a day for it to cool it down. It just doesn't work very well under those conditions. Refrigerant charge is critical, and since it's a small system and so little refrigerant, it's really easy for the charge to be off. And there must be a full column of liquid to the cap tube. That's also important, but that's tied to the refrigerant charge. Okay, so if you have a cap tube system and it's flooding, here's some of the things that cause it. And one of the things you want to keep in mind when you're working on a cap tube system, these are small refrigeration systems, and every time you need to try and avoid putting your gauges on, because when you take the gauge off, you lose refrigerant, and there's such little refrigerant that can affect the system quite a bit. So what you need to do is use your head and use your eyes. So if you have too much high side pressure, and you can do that by clamping your temperature probe on there, you need to look for a dirty condenser, and it's a possible refrigerant overcharge. The incorrectly sized cap tube, you're not really going to find that unless you've talked to the owner of this equipment and they just had someone recently work on it and replace the cap tube. That would be when you'd want to check that. And low evaporator load, that's just when you have dirty or iced evaporator, bad fan motor, or you have a really low box temperature. Okay, so starving cap tube system. So this is when the door's left open for too long, or they have a bad door seal, so you need to look at that. You also need to ask, when did they put the product in the box? Did it come from a cooler, or did they just take it from room temperature and put it in a box? Again, it can take 24 hours for that to cool that product down. Of course, if it's low on refrigerant, that's going to cause the problem. And again, incorrectly sized cap tube, and that's if someone has replaced it and made a mistake. You won't normally find that if it's a system that's been operating properly for years on end. Okay, so the most common cause of cap tubes problems, refrigeration problems, is the blocking of the cap tube, and that's because the cap tube inside diameter is so small that it can get plugged up. Here's what it looks like. This right here is connected to the outlet of the compressor, and this is where you have the liquid coming in, subcooled liquid refrigerant coming in to the filter dryer. Now this is a tiny filter dryer and has this beaded desiccant, and sometimes the powder and such can flake off of these beads, or they'll crack and a little piece will come off, and it'll clog the inlet of the cap tube. So you can check that by checking the temperature drop from the inlet to the cap tube to the a few inches down, and if you see a large temperature drop, you know that this part of the cap tube is blocked off. So what you do is you cut off an inch or two of the cap tube right here and unbraze the plugged portion, and then braze in the rest of the cap tube. Now an inch or so of cap tube isn't going to make a big difference on your the pressure drop and affect the temperature of the system very much. So you're safe to do that. The one thing you need to make sure that you do is you push in enough of this cap tube so that when you braze, it doesn't plug up this small end, and you also need to make sure that you don't push it in too far so it's not smashed up against the screen that holds the desiccant in. Okay, so when you're going to be cutting a cap tube, don't use tubing cutters. You need to score it, and then you put it between your you score the cap tube and you hold it between your thumb and forefingers with both hands, and then you could snap it off. And there's also cutters for the cap tube, which are much easier to use. So here's what you use. Use a file to score it, or your cap tube cutting tool. Alright, so if you use a tubing cutter, it's going to compress the inside diameter of the cap tube, and that's going to cause issues with your pressure drops. Okay, so just before we finish up, if you're on a system and you can't find the size of the cap tube, there are cap tube diameter checkers so that you can slide it on here and check the outside diameter of the cap tube, and then they have the little keys here to slide into the cap tube to see what size it is. So that's it. 15 minutes on the capillary tube metering device. Any questions, please email me or get on the free student forum and ask some questions. Thanks a lot.
Let us continue. Few problems of the psychometry. That is 4.9. Let us start. Here, the problem is 16.9 of done 6.10. At atmospheric air with a dry bulb temperature of 28 degrees centigrade at a wet bulb temperature 30 degrees centigrade is cooled to 15 degrees centigrade without changing the utterance content. Means its relative humidity remains constant. The amount of moisture present part with its weight to the amount of moisture is supposed to be present when this time weight is fully saturated. The relative humidity is more or less remains same. The moisture constant remains same. So original relative humidity first of all, final relative humidity, and it is final bulb temperature. Now, the TD1, the original bulb temperature, final that is 20 degrees centigrade, and final dry bulb temperature is 20 degrees centigrade exactly. That is plotted here. It's on that wet bulb temperature, dry bulb temperature line, and one drop a particle here, and the wet bulb temperature is 70 degrees also plotted here, and drop a more or less particle which intersect here, and it will reach the nearest to the relative humidity line over the psychometric chart. Now, the final coordinate drawing horizontal point and 5.3 ঠিক আছে original relative humidity line from the psychometric chart to find that the relative humidity had find equal to 34.34%. From final relative humidity plus psychometric relative initial relative humidity was at 0.2 final. So we have to make a horizontal line from the point 1 which will intersect at the wet bulb temperature line T2, which and is cooled to 15 degrees centigrade. That is 15 degrees centigrade here, and drop this line, and this horizontal will intersect each other at the point 2, and we nearest to the relative final relative line at point 2, which is 17 degrees centigrade. So the self-reading chart, so we find that final relative time at point 2 is equal to 12.2 degrees centigrade. Now, from this temperature, the temperature point is equal to 0.2. The moist air is heated, next bulb is 16.11. The moist air is heated to a steam condensing the moisture heated by steam condensing inside the tubes of the heating coil. Now, the part of the air passing through the coil and part is bypassed around the coil. The adiabatic pressure is 1 bar. Therefore, the air per minute is which is bypass the coil and the heat added to the coil. Solution first given is 60 first year hidden part of it by the given first of all 56 degree centigrade degree Kelvin here in inches. Shown in the figure is the here 60 kg plus tricolor temperature 5 degrees centigrade, phi 1 is 100%, and phi 2, phi 3, which is going out at steam releasing height, that is phi 2, phi 3 is 20%, TD2 is going out temperature TD3. First of all, the initial condition of pair at a dry bulb temperature of 5 degrees centigrade, 10 degrees, 100 degrees centigrade, the humidity. First, the initial condition of where at dry bulb temperature 5 degrees centigrade, 100 degrees relative humidity is marked at 0.1 in the psychometric chart. So it is 0.1, 5 degrees centigrade, 100% relative humidity line is line, you call this line. So it is correct to make this point H1. And it is equal to the enthalpy line, the enthalpy is observable. Now, in 1 kg of air being at 0.1, since x kg of air bypass unaffected by dividend 1 minus this coil over the heating coil. Heating coil rises the temperature to a dry bulb temperature from TD3 at stage 3. It is given TD3. It is unknown to us, and relative humidity at 0.3 is given as 20%. So on the point line, there is a line is given, but we have to find out the 0.3 here. In unheated or bypass is mixed with the air, it is there within the final condition of air at 0.3, having a dry bulb temperature 24 degrees TD2, 24 degrees centigrade. It is 24 here. The condition of 0.3 is obtained by drawing constant specific humidity line from 0.1 intersects the vertical point of TD2 at 0.2 and 20% at 0.3. So cybernetic chart, if you drop a vertical 0.3, you'll get the temperature of the heating coil at 0.3. The enthalpy at 0.1 is given. Enthalpy at 0.2 is also available, and 0.3 that's also available by dropping particle from the enthalpy chart. Air per minute which bypasses the coil. Now x is equal to TD3 minus TD2 divided by TD3 minus TD1. We put the value of TD3, TD2, TD3, and TD2, and got the bypass factor as equal to 0.262. Air which bypasses the coil, x multiplied by MA is 15.64 AG per millimeter, where 60 is the total volume of air which is passing. Heat added to the coil is given as MA H1 minus H2, MA is 60, H1 is given at 11.40. That is 11.1140, 1140. Next, 16.22. 12. The atmospheric air, 760 kg of barometric pressure, dry bulb temperature 15, and wet bulb temperature 11, and enters a heating coil whose temperature is 41 degrees centigrade. Assuming bypass factor of heating coil is 0.5, and determine the dry bulb temperature, wet bulb temperature, relative humidity of air hitting the coil. Also, temperature sensitivity added per kg of the air here. So, given the atmospheric pressure 760 kg of Hg, and TD1 is the dry bulb temperature 50 degrees centigrade, and TW1 wet bulb temperature 11 degrees centigrade. Both are given here. And TD3, the temperature at the heating coil 41, and bypass factor is 0.5. The initial condition entering the coil at dry bulb temperature 50 degrees centigrade of the first time, and fit level 60 centigrade of the dry bulb wet bulb line, and it is intersected at 0.1 here. Now, draw a constant specific humidity line from 0.1 to the vertical line from through 41. So 41 is the one vertical line here and draw a horizontal line which intersect at point 3. To point 1 and it's at point 3. The point 2 lies on the section 2, 3. Now TD2. The triangle here defeats the coil. We know the bypass factor. The point 1, TD3 and TD3, TD2, TD3. Where TD3 is given as 41 and 41, TD2 is unknown to us, TD1 50. So TD2 will get 28 degrees centigrade. So you put the value of TD2 here. Now from the chart, the 12 millimeter they are leaving the point 16 is from the point 2 and it will drop the vertical, it will reach first sector here 16.1 degrees centigrade. Relative velocity of the air leaving the psychometric chart, we get the relative velocity of the air leaving the coil, which is the phi 2, which is intersected by the point 1, that is 28 degrees centigrade. And the sensible heat added to the air heat added to the air per kg of dry air is the substitute charge at point 2 is 46 degrees at 41 degrees, and the heat added to the per kg burn is difference between these two is 14.2 kilojoule per kg of dry air. Next, let us go through the relative humidity line. Humidification and dehumidification. The addition of moisture to the air without change in its dry bulb temperature is known as humidification. So without changes dry bulb temperature, the addition of moisture is known as humidification. Similarly, removal of moisture of air without change in its dry bulb temperature is known as dehumidification. So dry bulb temperature or its temperature is supposed not to change, but if we add moisture, it will be humidification. Remove moisture, it will be dehumidification. Heat added during humidification process, heat through the process is shown in the cytometric chart in figure. It may be noted that in humidification, the relative humidity from increases from phi 1 to phi 2. This is what it was relative process when moisture is added. Humidity means the amount of moisture present, ratio of the amount of moisture actually present in the dry air in the air pure mixture to the moisture which is supposed to be present, which is fully, if the mixture is fully saturated, then it is called relative humidity. So it is increased from phi 1 to phi 2, and specific humidity from the chart, the amount of moisture present was improved from W1 to W2. Similarly, during its humidification, the relative humidity decreases from phi 1 to phi 2 to phi 1, and specific intervals reduces from W1 to W2. Humidification increases phi 1 to phi 2 to phi 2 to phi 1. Decreases from phi 2 to phi 1 and reduces from W2 to W1. It may notice that the integration change in enthalpy is shown by the intercept H1 minus H2 in the psychometric chart. Since dry bulb temperature of air during integration remains constant, therefore its sensible heat also remains constant. It is thus obvious that the change of in enthalpy